Don't press Mother Nature, a lesson on how to avoid VFR into IMC with WeatherSpork flight planning and SiriusXM Aviation weather. Hello, this is Scott Dennstaedt, CFI and former National Weather Service research meteorologist and co-founder of the new WeatherSpork app. According to the 2017 NOAA report, VFR flights into instrument meteorological conditions, or IMC, continues to kill more pilots than all of the other causes of weather-related accidents combined. Mother Nature does not discriminate. She doesn't care if you are a brand new private pilot, seasoned professional, or somewhere in between. Once a decision is made to launch, all pilots flying under visual flight rules must see and avoid IMC. The key to minimizing your exposure to these adverse conditions is to do a thorough analysis of the weather prior to departure, develop a flexible plan, and monitor flight conditions while en route with a data link weather solution such as SiriusXM Aviation Weather. To illustrate how to do this safely, let's examine a 350 nautical mile flight under VFR from Ardmore Municipal Airport in south central Oklahoma headed to Columbia Regional Airport in central Missouri. Using the new WeatherSpork app, let's first start out with an analysis of the weather for this route and develop a working plan. Assuming the weather is suitable for a VFR flight, we'll take that plan into the cockpit and monitor the flight conditions while en route using SiriusXM's satellite weather broadcast connected to the Garmin Pilot app. It's November the 19th, and the time right now is about 19Z. We plan to depart in an hour at 20Z or 2 p.m. Central Standard Time. Based on some earlier flight planning, the VFR flight should take a little over 2 hours. But it's important to land before the sun sets at 23Z or 5 p.m. So that places a reasonable but tight schedule on the flight. In the WeatherSpork map view, we'll enter the two airport identifiers, namely KADM and KCOU, using a direct route to begin this pre-flight weather analysis. The goal at this point is to see if this flight can be completed under VFR. For the sake of brevity, this won't be a complete analysis of the weather, but this will give us a pretty good estimate of the weather challenges on this flight. Typically in November, deep moist convection or thunderstorms are not the primary concern, but making a VFR flight this time of year requires a keen eye for the potential of IFR conditions. As such, there's no need to press on and fly VFR into IMC. Just a quick note, for flight category, WeatherSpork uses the same colors as is used by the Aviation Weather Center. That is, green means VFR, blue marginal VFR, red IFR, and magenta low IFR. Remember that the flight category takes into consideration both ceiling and visibility. The square markers along the route in WeatherSpork are called proximity airports and provide an indication of the forecast flight category at those airports at the time the flight is expected to pass by. The circular markers, on the other hand, are showing the current flight category based on the latest surface observations, or METARs. When sliding the patent-pending Wheels Up Departure Advisor to the right by an hour from 19Z to 20Z, the flight category markers now show a forecast valid at 20Z. So a quick check of the observed flight categories as of 19Z indicate VFR conditions along the first half of the route, with marginal VFR conditions as we approach our destination of Columbia, Missouri. More important, notice that there's an abundance of airports reporting a VFR flight category to the north and west, whereas south and east of the route are mostly marginal VFR with some IFR conditions directly east of the destination airport. This gives us some confidence that the best alternates will be to the west and northwest if the latter half of the route cannot be made under VFR. Consequently, this is where we will likely divert if adverse conditions are encountered. The WeatherSpork grid view is another way to depict the same basic weather guidance. With Ardmore at the top, Columbia at the bottom, and proximity airports in between, a departure after 20Z will miss the earlier marginal VFR conditions shown by the blue squares. Before we get into the details, it's always important to assess the big picture or synoptic weather overview. This is best accomplished using the comprehensive WeatherSpork imagery to see the major weather systems that might have an impact on the proposed route. Today's national forecast chart shows a cold front extending from New York City west-southwest through the Ohio Valley, and then southwest to the lower Mississippi Valley. Some rain and some thunderstorms are expected along into the east of the cold front, with some snow extending from northern Kentucky through the mid-Atlantic into southern New England. High pressure exists along the route from Ohio to Missouri, with another cold front extending from southern Ontario west to the upper Mississippi Valley and then northwest into the northern high plains. Consequently, the route is squeezed between two major weather systems with no significant precipitation expected along the route. To assess the recent trends in the weather, let's look at the surface analysis loop repeated a few times here over the last 24 hours. This starts out with the oldest chart, valid at 21Z yesterday afternoon, and progresses through 18Z today. Notice that the cold front south and east of the route makes very little forward progress. High pressure along the route weakens a bit in the middle Mississippi Valley, which allows the northernmost cold front to progress quickly to the south, ushering in much colder air from Canada on the northern side of the cold front. To see how this weather is expected to evolve, the short-range prog charts from the Weather Prediction Center will help. This forecast is valid at 0Z, or 6 p.m. Central Standard Time. That's shortly after the planned time of arrival in Columbia, Missouri. The primary precipitation areas are associated with the cold front to the south and east of the route, with the highest probability occurring in the lower Mississippi Valley and through the mid-Atlantic. High pressure over the route is expected to weaken further, with the northernmost cold front expected to approach our destination. However, no precipitation is expected to occur with this cold front at this time. A surface pressure trough is oriented along the route and represents no significant threat. A surface trough such as this doesn't separate air masses and typically represents only a shift in the wind direction, along with a change in pressure along the trough axis. Given that the prog chart was valid at 0Z or after we plan to arrive, it's also good to check the Quantitative Precipitation Forecast, or QPF. This shows the amount of precipitation or liquid equivalent in inches expected to reach the surface between 18Z and 0Z. This is perfect since it encompasses the entire duration of the flight. Similar to the prog chart, it only shows the potential of precipitation along the cold front to the southeast, keeping the route free of any significant precipitation. The latest radar mosaic depicts that most of the precipitation is occurring along and ahead of the cold front. However, it does depict some light precipitation near our destination. This doesn't appear in any of the forecasts and something we'll have to keep an eye on after we depart Ardmore. We want to be sure that it doesn't intensify and reduce visibility or cause ceilings to build down as we approach Columbia. Now let's turn our attention to en route advisories. Forecasters at the Aviation Weather Center issued what are referred to as graphical airmets, or GAirmets. These advisories replaced the legacy airmet back in 2010 as the operational en route advisory forecast for IFR conditions, mountain obscuration, turbulence, and icing. Unlike airmets that are valid over a 6-hour period, they are snapshots valid at a single time, which provides a much better temporal resolution than the legacy airmet. On the WeatherSpork map view, you can overlay the latest GAirmets issued. In this case, a GAirmet was issued for widespread IFR conditions valid at 18Z, located just east of the route as denoted by the dashed purple polygon. Therefore, within this area, pilots should expect ceilings less than 1,000 feet and or visibilities less than 3 statute miles at 18Z. This nicely encapsulates many of the red and magenta flight category markers that are currently reporting in IFR and low IFR flight category respectively. If we move the wheels up departure advisor to the right by an hour so that it matches our estimated time of departure of 20Z, then you'll see that the IFR GAirmet shifts further to the east, implying improving conditions east of the route. Even so, there are still a few airports along the route, including our destination, expected to be marginal VFR or even IFR for a 20Z departure. For example, Springfield, Missouri is expected to have a ceiling greater than 12,000 feet, but the surface visibility is expected to be only 3 statute miles. And at Columbia, the ceiling is expected to be 2,500 feet, but greater than 6 statute mile visibility at 20Z. But just 46 miles southeast of Columbia at the Rolla National Airport, an IFR ceiling of 700 feet is expected. If we move the WeatherSpork airplane along the route to simulate the changing weather conditions during this flight, notice that about halfway, the surface visibility at Springfield is forecast to improve to 6 statute miles with clear skies. And by the time we reach our destination, the ceiling at Columbia is forecast to be a generous 9,000 feet. The WeatherSpork route profile also depicts this trend nicely. This is a vertical profile of clouds, visibility, freezing level, and wind that are expected along the immediate route. In this view, the departure airport is on the left and the destination is on the right, with proximity airports shown in between. The brown area at the bottom is terrain along the route, and on the left is the height above mean sea level in thousands of feet, increasing from the bottom to the top. Areas of bright blue in the profile view indicate a good chance of clear air, and bright white indicates a high likelihood of clouds at the altitude depicted. Using a 19Z departure and arrival shortly after 21Z, the Spork readout or vertical data pole shows the 9,000-foot ceiling expected at Columbia, and also shows the 3 statute mile surface visibility passing by Springfield. Even though this profile view makes the route look very promising, we know that from the big picture that the flight will be on the edge of some marginal weather that we can't forget. Given the lack of clouds on the first half of the flight and with tailwinds expected, the plan is to fly initially at 7,500 feet, knowing that a descent may be necessary to fly below a lower cloud deck or divert when approaching Columbia if this forecast doesn't hold true. Next, it's important to drill down further at our destination using the WeatherSpork airport view. The latest surface observation, valid shortly before 19Z, reports an overcast ceiling at 2,400 feet with 10 miles surface visibility and a southwest breeze at 8 knots. The meteogram for Columbia shows how the weather is expected to change at the airport over time. On the left at 20Z, the marginal VFR ceiling is expected to be 2,500 feet and then increasing to 9,000 feet by 21Z and later. Surface winds are expected to be 260 degrees at 8 knots with a 7-knot crosswind. The terminal forecast or TAF issued at 18Z for Columbia is similar to the guidance in WeatherSpork in that it shows VFR conditions with a temporary broken ceiling of 2,000 feet between 18Z and 20Z. The 21Z forecast sounding for Columbia, as shown on the WeatherSpork SKU-T log-P diagram, keeps a thin layer of clouds at 4,200 feet MSL, which equates to a ceiling of 3,300 feet. Then by 0Z, that layer of clouds begins to deteriorate. Given all the weather guidance examined so far within WeatherSpork, along with a call to flight service, the plan is in place for a 20Z departure out of Ardmore, Oklahoma. As is often the case, we're running about 30 minutes late. That gives us a departure around 20:30 Zulu and arrival at our destination just before sunset. So right after we get into the airplane, we launch our Garmin Pilot app and start receiving the SiriusXM satellite weather broadcast through our Garmin GDL52 portable receiver. Even though we've done a thorough pre-flight analysis of the weather and received our telephone briefing, the weather analysis doesn't end until we get safely on the ground in Missouri or at our alternate destination. With no altitude or look-ahead limitations and no line-of-sight restrictions that are sometimes problematic with ADS-B weather, the SiriusXM satellite weather broadcast keeps you seamlessly informed of the weather along your route at your destination and allows you to monitor the weather at your alternate airport. The SiriusXM weather broadcast is a perfect tool to monitor the flight conditions along the route. When I fly VFR, I like to monitor 4 layers. First, the clouds layer provides a good overview of the extent of the cloud coverage. Second, the weather layer allows you to monitor all the latest surface observations along your route and at your destination and alternate airport to include ceilings, visibility, and cloud coverage, just to name a few. Third, the radar layer will tell you where precipitation is occurring. This is important since low ceilings and poor visibility may accompany widespread areas of precipitation. Fourth, the AirMet layer contains advisories that include forecast areas of widespread IFR conditions and mountain obscuration. As we are taxiing to depart, we notice that our route cuts through the western side of AirMet Sierra as shown by the shaded polygon, implying widespread IFR conditions. Keep in mind that Garmin Pilot provides the legacy AirMet, not the higher temporal resolution G AirMet. However, based on our weather analysis prior to departure, the widespread IFR conditions are expected to shift further to the east as depicted in the WeatherSpork app for 18Z and 21Z. The legacy AirMet, on the other hand, covers the entire 6-hour period from 15Z to 21Z, therefore depicting a larger region, which includes the latter half of the route. Please note that Garmin Pilot uses a different color coding for flight category than the WeatherSpork app. In this case, VFR is blue, marginal VFR green, IFR yellow, and low IFR is red. Similar to the WeatherSpork guidance, VFR ceilings prevail over the first half of the route with marginal VFR over the remainder of the route. Springfield's latest surface observation reports an overcast ceiling at 1,600 feet, and Columbia reports a broken ceiling at 2,700 feet. We could alter our route slightly to the west, but we will still need to eventually turn back to the east to land at our destination. Also, it's important to validate that the weather sources are being received through SiriusXM in this case. You'll see this tagged as SXM. At this point, I like to make sure that the radar, clouds, and airport weather are displayed for that route. The only thing that is missing among my favorites for VFR flight is the cloud layer, so I'll turn that layer on and turn off the AirMets layer for now. Clouds are depicted here by shades of gray. Locations where you see brown are generally associated with clear skies. Consequently, the last third of the route shows some cloud cover, which matches the observations nicely. Also notice some light precipitation about 50 miles north of our destination in association with the northernmost cold front. That likely means deeper clouds that could affect the ceilings at our destination as that precipitation pushes south with the front. At 15 minutes into the flight, it's time to check the weather along the route. The ceiling at Columbia has improved to a scattered layer at 2,600 feet, with Springfield along the route reporting a ceiling at 1,600 feet. In addition to the ceiling, it's important to monitor the surface visibility. As noted during the pre-flight analysis, the surface visibility at the destination is at 10 statute miles, but Springfield is still reporting a marginal VFR category of 5 statute miles. It's also useful to monitor the age of the reports. Routine observations from an ASOS will typically be issued hourly, whereas observations from an AWOS will be issued 3 times every hour. If the weather changes from marginal VFR to VFR as it did in Columbia, a special observation will be issued and received via the SiriusXM broadcast. Consequently, the age of this observation at Columbia is 11 minutes old. If the age exceeds about 75 minutes, you'll want to look at the SiriusXM status page to verify you are still receiving METARs. This says that METARs were received and downloaded 10 minutes ago. At 30 minutes into the flight, we will once again want to recheck not only our destination, but alternates as well. There are plenty of airports to the west reporting good VFR conditions. However, while still marginal VFR, the ceiling at the destination bounced back from scattered to broken, but remained at 2,600 feet. The Springfield weather has improved a bit and now reports a broken ceiling of 2,100 feet. With all of the weather recently updated and slowly getting better, this gives us the confidence to continue the flight onto our destination. About an hour into the flight, we're approaching the midway point. Based on the SiriusXM cloud depiction, clouds have continued to erode over the last 30 minutes. But unfortunately, there hasn't been much change in the ceilings at Columbia or Springfield. No special observations have been issued, which means no significant changes to the weather at those airports. A decision is made to descend from 7,500 feet to 3,000 feet as clouds start to appear in the distance. Nevertheless, the alternate airports to the west are still looking promising if we need to divert. As we approach Springfield, a special observation is issued that takes the airport from broken to scattered at 2,200 feet. Visibility has slightly improved to 6 miles in haze. This matches extremely well with the WeatherSpork guidance seen during the pre-flight analysis, providing good confidence to continue. 10 minutes later, Columbia has also continued to improve and is now reporting VFR conditions with a broken layer at 3,500 feet and 10 statute mile visibility. While not as good as the 9,000-foot ceiling forecast we saw during the pre-flight weather analysis, the ceiling is favorable enough for us to continue a descent as we contact Mizzou approach and pick up the latest ATIS. With a surface wind at 220 degrees at 6 knots, we prepare for a landing on runway 20. This flight went as expected, thanks in part to a good weather analysis prior to departure and having SiriusXM weather in the cockpit to monitor the evolution of the weather during this trip. This flight originated in near-perfect VFR weather in Ardmore, Oklahoma, headed toward marginal VFR weather at our destination in Columbia, Missouri. Based on the guidance in the WeatherSpork app, conditions were expected to improve while en route. While there is always a risk of a poor forecast and changing weather, solid alternates were abundant to the west of the proposed route. In the end, the key to not being a VFR and IMC statistic is to start with a solid plan, be flexible with that plan, and monitor flight conditions with SiriusXM Aviation weather while en route. SiriusXM's satellite-delivered weather is always available in flight when you need it, with no altitude limitations or line-of-sight restrictions. Plus, it has coast-to-coast high-resolution radar and weather features that update faster than ADS-B, making it the best choice for pilots flying under VFR. To learn more about the new WeatherSpork app, please visit weatherspork.com. To receive a 2-month trial of SiriusXM Aviation Weather and Entertainment, or learn more about other SiriusXM specials, please go to aopa.org/SiriusXM.